Hello everyone. Now let's see how to build structure equation modeling with STATA. So first let's have a data set. Let's open it. Okay, so I do have a data set which contains around 6 variables. So now let's see how to draw structure equation modeling, especially the same for the continuous variables. So I'm going to use the graphical user interface approach, and then finally even we can see the command on how to draw a structure equation modeling by using this STATA software. So just to build our model, let's click on statistics and then go to structure equation modeling, and then next we should click on model building and estimation. Model building and estimation. Okay, so here is the interface where we are going to draw the structure equation modeling. So here we should be familiar with the icons which are placed here in the interface of the STATA window. So the first one, this SEM and GSEM. For example, when we are opening this interface for the first time, the same interface or the same syntax will be active for drawing the model for continuous variables. But if we are planning to use the GSEM approach, we need to click on GSEM. So when we click the GSEM, then it will be activated to be changed into non-linear approach, so that we can change GSM into SEM or SEM into GSM by just clicking on this icon, the SEM or the GSM icon. So now for the sake of this session, I'm planning to use SEM for the continuous type of outcome variables. And then in another video we'll see how to use the GSEM approach for the categorical or for the non-linear regression methods. So next to GSEM there's a cursor which is used to just select some graphical icons or some text, and then next to this cursor there's a rectangular shape. So this is used to draw an observed type of variables. That means a variable which is directly measured with a measurement tool, like age or monthly income, or maybe weight or blood pressure or serum uric acid level of a certain patient could be directly measured. So this rectangular shape is used to draw observed types of variables. And the next double rectangular shape is used to draw a generalized response variable. That means a variable which have a categorical type, maybe binary or multinomial, ordinal, count, whatever. Such types of data will be just drawn by using this double rectangular shape. And then the next circular shape is used to draw a latent variable. This oval shape is used to draw a latent variable. In the lecture or in the theoretical video, I said that latent variable is a variable which cannot be measured directly. Rather, we measure the variable with different items of questions, like measuring depression with Edinburgh postnatal scale, having 10 items, or maybe measuring anxiety with GAD-7 items of questions. Such types of variables are latent variables. So we need to just draw these types of latent variables by using this oval shape icon. And the next, the double oval shape icon is used to draw a multi-level latent type of variable. A multi-level latent variable. That means the variable is a latent type, but also it is nested in a hierarchical nature of data. So a multi-level structural data. So the variable is latent, and in addition it is a multi-level or a hierarchical type of data. So such types of variables will be drawn by using this double oval shape icon. And the next is a path icon, which is used to draw the path from the independent variable to the outcome variable, or just to draw or to point the effect of an exogenous variable, that means independent variable, to the endogenous variable, that is outcome variable. So we use this path icon in order to draw the association or the relation of one variable with the other types of variables. And the next is a curve or double-headed curve arrow, which is used to draw the covariance. That is the correlation or the covariance of two variables with each other. So that if we are planning to draw a covariance or a correlation between two variables, we are going to use this double-headed curved arrow. And the next icon is the measurement icon. This icon is used to draw the measurement model. The measurement model is a model which is used to draw a latent variable with its subsets of questions or items of questions. We'll see each of these one by one. Okay, the next is, in order to add observed variables, we need to just use this icon again. Once we have drawn an observed variable, if we are planning to add another observed variable, then we use these three rectangular shapes. And the next is three oval shapes, again are used to draw or add a latent variable. Once we have drawn a latent variable with this single oval shape icon, if we are just planning again to add another type of latent variable, then we are going to use these three oval shape icons. And the next one is just adding a regression component. A structural equation modeling have two components, the measurement component and the structural component. That is the regression or the structural component. So if we are planning to draw a regression component or a structural component, we are going to use this icon. And then the key icon is used to just add a text or to write a text in any drawn box of the model. Once we have just drawn either the observed box or the latent types of variables with these icons, we can add a text or write a text over them. So in order to just add a text, we are just going to use this add text icon. And again, the last one, the add area icon is used to just add the area. That means this interface of the SEM builder will be just having more space. So in order to just adjust or add area of this interface, we are just going to use this add area icon. So these are the most important icons or diagrammatic representations or language usages for structural equation modeling. So now I am planning to draw a structural equation modeling which is same for a continuous types of outcome variable. So now let's see how to draw. So since I have considered the variables as directly measured variables, like just observed variables, I am planning to use this rectangular shape. Okay, so in order to draw this structural equation modeling with this observed icons of rectangular shape, I need to just select by clicking the rectangular shape. So once I have selected this, then I need to draw. Since I do have 6 variables within the data, I do have, or I need to just draw 6 rectangular shapes here. 3, and again, okay. So once we have finished drawing these boxes, we need to deselect this icon. In order to deselect the icon, we should click on the cursor, the select cursor, this one, the arrow. So now it is deselect, you know. So hereafter, the rectangular shape is deactivated. Therefore, additional boxes will not be drawn here. So hereafter, I can move the boxes where the place where I want to put. Okay, in such a way that it will be appropriate for drawing paths for each variables. Okay. Now, after just drawing these boxes, we need to put the variables inside the box. So, if we have already opened the data within the STATA software, like here, we do have 6 variables: the support, PTSD, depression, anxiety, fear of birth, who does total score. So there are 6 variables. Since there's a data set in the software, so the variable list will be displayed there in the SEM builder. For example, let me put, in order to just put the variable within the box, you should select the box first and then go to the window here. Here is a variable. So by clicking here, the list of the variables will be displayed. The variables opened within the STATA will be displayed here in the SEM builder. So in the last box, I wanted to place the PTSD. So when I select the PTSD, it will be placed inside the box. And then again here, let me select the box. And then let me put maybe depression here. And then in this, the third box, place the anxiety variable. And then here, maybe the who does total scores, the WHO disability assessment schedule. And then this box, let me put again maybe social support. And the last box, what remains is maybe fear of birth. Yeah, fear of birth. So the variables are placed within the box of each observed variables. So, but it is an assumption that depression, PTSD, anxiety are just taken as an observed variable. But in reality, they are not observed variables. They are a latent variable. So we will draw a measurement model and a structure model for these variables in another video. But for the sake of an explanation and just for the sake of an example, I have considered this depression, anxiety, and PTSD as just observed variables, just for the sake of example. But in reality, they are not observed variables. But I am just intending to show you how to draw observed variables for the structure equation modeling function. Now, what remains is drawing the path in order to show the association or the relation, the cause and effect relationship between variables. Be sure that while we are just drawing the path from one variable to another variable, the path or the connection or the relation should be logically connected. That means it should be scientifically proven. The way we draw the path here should be supported by literatures. We are not just going to draw anything as we want. Rather, it should be supported by literatures, it should be supported by scientific findings. So our way of drawing the paths is based upon previous research works and research findings. And it should be logically and scientifically proven or supported. Just having this in mind, just for the sake of showing how to draw the connection, let's click on the path, add path. And then let's assume that depression could cause PTSD, anxiety could cause PTSD. Once we draw the path, there will be an additional symbol which is symbolized by the error term E. That means the error term associated with just estimating the outcome variable PTSD. Okay, now social support again could affect depression. That means depression have a direct effect on PTSD. Okay, social support could have also a direct effect on PTSD, but social support could again have an indirect effect through depression. Okay, social support could have an effect on fear of birth, positively or negatively, and then fear of birth could also have an effect on depression. Fear of birth again could have an effect on anxiety. Fear of birth could have also an effect on PTSD. Disability assessment schedule, finally, fear of birth could have a cognitive dysfunction effect or a positive or negative effect on who does assessment, and again maybe who does total score could affect maybe or could brought anxiety, and disability could again could brought a depression. Being disabled could also brought a PTSD. So we can draw as much we can draw a path depending on scientific explanations and literature supporting evidences. We can draw in such a way. So this is a way how to draw our paths from one variable to another variable. So now PTSD is the last outcome variable. All paths are directing to it, so it is said to be endogenous variable or an outcome variable. Okay, anxiety is have an effect on PTSD. So anxiety could be taken as an exogenous variable for PTSD. That means an independent variable for PTSD. But similarly or simultaneously, anxiety is an outcome or endogenous variable for HUDA's total score and for fear of birth, because there are paths directing to anxiety. That means fear of birth could affect anxiety, HUDA's total score could affect anxiety. So anxiety is simultaneously at the same time it is an outcome variable and then an independent variable. So in structural equation modeling, a variable could be both endogenous and exogenous variable. So this is a way how we can draw a structural equation modeling in SEM builder. So after drawing our structural equation modeling in such a way, the next thing that we are going to do is estimation of the beta coefficients associated with each connection or a relation or path drawn. So now in order to just estimate the beta coefficients for each path, we do have two possibilities or two ways of estimation. The one is, being here in the SEM builder, we can click on estimation and then we can say estimate. The next, another option or the second option is going to the STATA window. We can click on statistics and then go to structural equation modeling, and then testing, estimation, model building and estimation. And after just clicking on model building and estimation, we'll just go to the next window, which is the interface that we have seen previously. So as usual, we can click on estimation and then estimate. So here another interface comes after just estimation options. So now the model uses the maximum likelihood estimation model. Structural equation modeling use the maximum likelihood estimation method to estimate the beta coefficients. And if we do have multiple options here, the standard error estimation technique by default standard errors we use, but there are other options, especially the last one, the Satora-Bentler estimator correction will be used if the data is not normally distributed. So before running our structural equation modeling, we need to check whether the outcome variables are normally distributed or not. If the variables are normally distributed, then we use the default standard error estimation method. But if the data is not normally distributed, the Satora-Bentler estimator will be used because it corrects the non-normally distributed data. So for this example, just let's use the standard error estimation method, and then reporting, we can just display the standard beta coefficients and p-values or unstandardized one by just clicking on these boxes. So now going back to the model, and by just choosing the maximum likelihood estimation method, click on OK. It will take a while to just browse yeah, final estimation beta coefficients. So now the beta coefficients are displayed in each path. So that means, for example, the path drawn from the social support to the depression is 0.4. With a unit increase in social support, so the depression level will increase with amount of 0.4. That means if the beta coefficient is positive and negative, the interpretation is similar with any regression analysis method. So the beta coefficients are displayed here, and maybe the values within the rectangular shapes are the constants, and the mean values and the variance. Like for example, the details are displayed here. The mean value is 11.26. So within the social support box, 11 is the mean value, and around 4, 3.9 is the variance, the standardized variance, and the standardized mean is 5.6. So that means the variance and the constants are placed within the box or the rectangular shape of each variable. And again, for the depression, because it is estimated, the intercept is placed within the box, and it is negative 5.5. So by clicking on each of these icons, we can see the details of the beta coefficients, the intercepts, the variances, and the error terms. So just you can exercise this by just doing it again and again, and the details of each values will be displayed here. One important thing that I want to show you here is we can choose what types of values should be displayed on the paths of each variable. Just by clicking or selecting this path, for example, or you can just at a time select all of these paths, or just by controlling, by holding control and then selecting each path, we can select what type of value should be displayed over here. So let me double click over here, and then after double clicking, and another interface will appear, and click on appearance, and then click on customize appearance, and then set custom appearance. And over here we can just add or minimize the widths. We can choose the color for the path, and we can adjust the size of the row, the bar size, the bar widths. We can increase or decrease by just clicking over here. By clicking over here, there are options. So we can choose the color even, and we can increase or decrease the row and the line. The width for the line, the width and the size for the arrow could be adjusted. And the results, as you can see, the default result displayed here is only the beta coefficient 0.4. So what should be displayed could be changed here. Result 1, it says the parameter, so only the parameter, that is the beta coefficient, is displayed, but I can choose the parameter with confidence interval, or the parameter with standard error, or the parameter with standard error and the p-value. A number of options are here. So let me just choose parameter with confidence interval. Parameter with confidence interval. And then apply. And then OK. And then OK. So have you seen the beta coefficient within the confidence interval? The confidence interval within the bracket is displayed here. So in order to display the beta coefficient with confidence interval for all the paths, we should select all the paths by holding the control key. So after just selecting all these paths, we can just set, sorry, not the control, the shift key. You can hold the shift key and then select all the paths, and then you can change. Okay, now I'm just selecting all the paths by holding the shift key, and then okay, Now all the paths has been selected. So let me click on the properties, and then click on appearance, and then click on customize and set customize appearance, and then click on results, and then result 1, it says parameter. We should select parameter with confidence interval, and then apply. Yeah, even we can adjust the angle or the alignment of this beta coefficient with confidence interval by just clicking on the custom again. So we can display the beta coefficients with confidence intervals in such a way. So this is a way how to draw structural equation modeling and how to estimate the beta coefficients with confidence interval or with p-value, whatever it is. So now hereafter, what we should do is we need to just calculate the direct effect, the indirect effect, and the total effect. So calculation of the direct, indirect, and total effect will be just made with next video. So this is all for this session. Thank you for watching.